The Flight The Flight of the Astronomers by Mark Wagner. She walked in and pushed an elevator button. She wore a transparent poncho with short, ragged wings hanging from her shoulders, nothing beneath. You look out upon the universe, but the more you look, the more you realize that the lens you look through is suffering. And the lens is other lives, the ones who have left, and the lens is a soft rain that keeps you awake all night. You've spent your life looking upon the all there is, but it's the all there is from 10 million years ago or longer. And he began to drift, dreaming long strands of dark matter that trail the earth as it drifts face down through space. And soon you see your mother's dark hair as she's brushing it. She's making ready. She's somewhere beyond you. There's a room she's preparing, as when your nursery was being prepared. Not many people know that astronomers collect bits of silk and web all their lives, and close to the end, weave them into wings. And then they look until they find a high point. Once in a while, you see them, but they're distant. You think they're only seeds on the air, she said, as the elevator doors opened to the roof. This was a poem by Mark Wagner and artist Rachel Single. You can see the rest of this. This artwork is actually pretty nice. I wish I could claim credit, but I did not. All right. That commentary aside, who are you actually, who's actually talking? Well, naturally, it's myself. It's Shen. You're watching SG2 on Space, episode 182. And today's, so before I actually go on, this is the only weekly space show. You can see us on youtube.com/@shinga/streams. And obviously, each episode has a different direct link, but if you go there, you can always see what the latest updates are, is the latest episodes. And all SG2 on Space shows will have, the name SG2 on Space on there. Been doing this for a few years now, so definitely we'll have to thank you to a few of our past supporters and patrons, Kyle Baker, Sam Welsh, and Atum Ra. And before I go further, of course, I need to bring the other person on who normally has something interjecting right now. Is there a voice? Is he just not talking?
Hello.
Okay, there you go. Now he's talking. What's going on?
What's going on? Hey, Shen.
Right.
Are we doing the show again? What are we going to talk about today?
Right. So we're doing the show SG2 on Space, right? Yeah. And today's topic. Oh, by the way, support the show patreon.com/SG2 on Space. All right. Yeah. So be part of the ones who are helping to make space more accessible to the public, which is our purpose for the show. If I've never said that before, I've said it just now.
I think in an
entertaining way.
Mm-hmm.
So
we try to be entertaining.
Nice headband. I just have a Star Wars hat, but Leonard has his signature headband on, which means he's well prepared to talk about any topic.
Pretty much. What did you want to talk about?
We're talking about space elevators today. I know we discussed this maybe a year ago. It's been a little while, but it's a topic that both you and I find quite fascinating. So I also found it really interesting that the guy who came up with the rocket equation, the Russian person,
Velikovsky.
There you go. He also came up with the concept of the space elevator. So what is a space elevator?
Well, it's like, your first thought is space elevator. That's crazy. How could you have a space elevator? I first became acquainted with it probably as a early teen in a book by Arthur Clarke called Fountains of Paradise. And so in there he talks about it's a structure that in the modern sense of it, it's a tether that's attached to a geosynchronous satellite. Geosynchronous satellites are at an orbit that rotates at the same rate that the Earth rotates. So in low Earth orbit, the satellites will orbit very quickly. They go around, like, for example, the space station orbits in 90 minutes, but the Earth rotates in 24 hours. So as you get higher and higher in orbit, the orbits are slower and slower. So in the case of the moon, which is a satellite of the Earth, it's a whole month. It takes a whole month to go around. So somewhere in between, there it is. And I read this book probably when I was I was really into science fiction when I was growing up. But anyway, so the moon orbits in a month, 28 days, and space station orbits in 90 minutes, and somewhere in between there's an orbit that is exactly 24 hours, and that's called geosynchronous. And if you're at the equator, then you're orbiting in the plane of the Earth, and you're at a particular point directly over the Earth, and it is theoretically possible to extend a tether down from the geosynchronous orbit, and you have to put a counterweight in the other direction so that it doesn't bring the center of mass of the system out of balance. So it's always orbiting at the geosynchronous altitude, which is something like 35,000 kilometers, more or less. And then you could extend this tether, basically a high technology kind of rope, extend it down. And then if you keep going thousands and thousands of kilometers, then people on the ground directly under the equator would see it up there. It would be extending down. It wouldn't be burning up because it would just be rotating with the Earth. And that you could actually then tether that to the Earth, to the ground, and then you would have a way of climbing this rope, as it were, all the way to the top. Now, that's not as simple as that, because you need very, very strong materials. And the history of this dates from I think in the late 19th century, by Konstantin Tsiolkovsky, who was one of the early Russian um, scientist.
I'm gonna find a picture of him. Keep talking.
Yeah, and so he thought the Eiffel Tower had just come online. The Eiffel Tower was a big deal in the 19th century because up until that time, the tallest structure in the world was the Egyptian pyramids, and they were made 3,000 years ago, 4,000 years ago. So and the way the Egyptians solved that problem of building up tall was, they made the base bigger and bigger and bigger, and so they got to a certain. He looks like an interesting gentleman, I guess. I like his glasses. I want his glasses.
I mean, that's one of his signature looks. I mean,
Yeah.
he looks really interesting.
Yeah. I want those glasses. That could go with my steam. That can go into my steampunk garb for sure.
He wasn't even trying, and he already looks
Yeah.
like he's wearing steampunk.
Yeah.
All right,
So
go on.
So anyway, so you can build a tower by making the base really big, and so he was considering looking at the Eiffel Tower, which was in Paris, and so that was a solution to the problem. Was they made this structure out of steel, and it was very innovative at the time, and it has the same kind of thing where the base flattens out and it goes up higher, and so he had this idea that you could keep doing that. You could build it higher and higher, and actually because gravity gets weaker as you get further away from the center of the Earth, you get some relief from it, but still you need to make the base wider and wider. And he actually did know that it was, with the materials that were known at of that time, that it was not possible to actually build something all the way to geosynchronous orbit, but he did come up with that idea. And then I think in the 20th century, there was another scientist in the late 50s, also Russian, who speculated, and I don't think that he published any papers. I'm looking for his name. It was yeah, I can't find his Artsunov. Yuri Artsunov, Arsutanov. Okay, and I don't think he was. He was an engineer and prominent, but he only speculated about this, and I think it was published like in a newspaper article in Russia, and it wasn't very well known. But what he had this idea was that, he had the idea that instead of having a compressive structure like the Eiffel Tower and building it taller and taller, that you would you would, because at that time people started talking about satellites, and so he came up with this idea of a space elevator that was built in the manner that I just described, where you would have a tether that would be extended downward from a geosynchronous satellite, and it would come all the way to the surface of the Earth. And so what you could do with this is that you could actually climb it, with some kind of technology using solar arrays or something that we really haven't, I don't know that that's been thought through completely, but you would have like a climber, or almost like a train, and it would drive along the tether all the way up to geosynchronous orbit, and then the forces of the orbit are balanced with the forces of gravity, and you could just step off and you're in orbit, and then from that point you could move to other places. Now you still have to use the energy to get to that altitude, but that can be supplied slowly, gradually acquired through either um, like beaming up through microwave, or just from solar powered or even nuclear powered systems or batteries. And so that's the idea. And so it's a fascinating kind of thing.
What is
um,
so you say we have the technology for it now, or
No, I
what?
did not say that. Okay.
Oh, whoops, sorry.
Um, at the time, they knew that steel was just not going to cut it. It does. So the difference between Silikovsky's concept was, a tower where everything is in compressive, is being pushed down. Okay, and then the Artsu Arsutanov's concept is something that's in tension. So you're actually, you have to pull it, and this tremendous amount of weight that has to be over a tether that's 35,000 kilometers long. It's a tremendous amount of tension, and so it does need to exploit exotic materials. Um, so it's completely at that time, it was still just a matter of speculation. I know that the idea actually was not well known in the West until I think there was somebody. I had a guy named Pearson at uh, at I think NASA Ames came up with this in the late 60s, where they were talking about, well, we could build this thing, and it seems like that concept was independent. In other words, it was in Russia but not well known around the world, mainly because that guy, he was an engineer, but he didn't publish in journals or anything. Like I said, I think it was just a newspaper article or a newspaper interview, maybe a TV interview. I don't know exactly. But this other guy, Pearson, uh, in the U.S., he published it in some of the space journals, and so the idea was that using exotic materials, certain kinds of very strong materials, and it would taper. So at the geosynchronous orbit, it has to be very thick, but it could taper down to something more manageable at near the surface of the Earth. And it doesn't have to be a circular. It doesn't have to be like cylindrical. It could be like a ribbon or something, or any kind of shape would.
You said a ribbon?
It could be, yeah, you could manufacture this out of a ribbon of material, and it would taper down. It would get thinner and thinner as you get closer to the surface of the Earth. There, you would want to do that because you'd want to relieve some of the weight that it'd have to carry. So I think that most materials, including Kevlar, all the kind of strong, yeah, there it is, where it tapers down, and you need a counterweight. So everything way at the top, that's above geosynchronous orbit, and then right at the place where the taper is the maximum, that's where the largest amount of
Hmm.
tension would be. But that's also the place where you're weightless, so you could just step off, but the tether would be in um under tremendous tension. So that's the idea. And the way, and we can't just put it anywhere. It has to be right at the equator.
Okay.
All right, but we'll return to that in a minute. There is a way to get around that in a certain manner. Um, but I just wanted to say that with the materials at that time, it didn't seem like it was possible. Now, Arthur Clarke, I think Arthur Clarke is the famous author who wrote 2001: Space Odyssey and so forth. Well, he also, I think he also collaborated with this guy Pearson in California, and they thought that they knew that they wouldn't be able to make it out of steel or any material like that, but they might be able to use um, there was some carbon nanomaterials. Clark talked about buckyball or nanotube type things, and those really came online in the late 80s and early 90s at Rice University under a guy named Professor Smalley, um, who actually, when I
You
was in
definitely
graduate
mentioned
school,
his name before.
yeah, when I was in graduate school at that time at Rice, and I think he was downstairs. I think his lab was immediately under my office. But
Was that
at
a good thing?
yeah, I mean, yeah, I mean, he won the Nobel Prize, and so it's thought that these materials, if we can construct them
Mhm.
uh, in mass quantities, we could assemble a tether,
Right.
and so it's just barely possible that this is um, a practical thing that could happen. So these are nanotubes. They're made out of carbon,
I
and
mean,
they're
obviously this is a 3D model, but
yeah,
but in the lab there are actual real materials made of nanotubes.
yes.
That is, yeah.
And so this is an area of active research and industrial, and there's the thought of industrial applications. And these materials are immensely strong in tension, and they may just barely have enough strength to make this thing a reality. There are a lot of people, you can go online, I'm sure, and find all kinds
Over
of
1,000 times stronger than steel, yet flexible like plastic.
yeah, so that 1,000 times, that's about what you need. I think it's tight. The tolerances are tight as far as being able to do this. Now that's at Earth. Now on the moon, I think it's almost a slam dunk that it would work on the moon.
We
Uh,
need to build a space elevator on the moon. I mean, I thought there's
yeah,
people who have talked about it. We could
yeah.
already do it. Yeah.
And also probably Mars is within reach of making a space elevator. So the thing about the moon is it doesn't rotate. It only rotates very slowly, and so the you need a much longer distance, but the forces, I think, are not as it's not as severe a constraint. But so anyway, that's a space elevator, and um, it's got some renewed interest
This
these
is
days.
a check this out. Two astronomers from Cambridge and Columbia, so they call it the space line. This is for the lunar one, and then they did all the math. But anyways,
Yeah, I think
um,
so anyway, I just wanted people to talk about. I know we did talk. Well, actually, I wasn't sure whether we talked about this before, but you informed me that we did talk about it a long
we
time
did.
ago. Yeah, I wasn't sure whether I had talked. I thought I had talked about it, but it might have been in a previous lifetime. Um, because
It's not. I mean, in a previous lifetime,
yeah,
we
there,
talked about
yeah,
many things.
yeah. So yeah, so you go through several cycles, right? And then according to Plato, you go through you
We'll
have to
check
go
this
through
out.
the river of forgetfulness,
Do,
right?
do, you, definitely. I
Yeah,
mean, otherwise I would remember it my past life, and I
and then
don't.
you're reborn, and then you're reborn. You're
Yeah.
reborn. So I
It,
held my breath going through that.
okay.
So
So I was going to point out to you that there are. I mean, moving aside from the river of forgetfulness, the talking about this stuff is something we have not addressed before. Like these actual companies, like this Japanese company Obayashi. I don't know if you heard of them. They're a very
yeah,
large construction company in Japan,
uh-huh.
and they in their website, this is literally their corporate website.
No,
You
I
can
didn't know
see,
about this, but there's all kinds of startups, all kinds of
yeah.
people trying to do stuff.
And I just
So
find it really interesting that a legitimate not some random dude, but a legitimate company that makes millions of dollars.
Well, correction there. We
actually
don't
has
know
this.
that this isn't a random dude. And
They're
also, random
not a
dudes.
random dude.
What?
This is a very large Japanese construction company.
Okay,
I'm just
and
saying
so
that this is probably one of their blue sky research groups
right,
or what
and
they
and
put
and they have
together.
people that go around the world and they try to get money to develop this thing, and I'm
So,
all about that. Okay, so
I mean,
you
yeah,
know,
let me see what their little animation.
hmm
I mean, it looks obviously you gotta pay somebody who makes these beautiful. Okay,
there it is.
that's it. Let's see what happens.
It's real. It's a photograph, right?
Yeah, yeah.
So that's
Look at
anyway.
that.
Yeah, so that's the
That's their
oh, this is
concept.
excellent. Yeah, this is the
Yeah,
concept. Now, yeah, so as you get higher up, it has to be tapering. It has to be getting thicker as you go higher. But maybe they didn't know about that. So they have a big solar panel there, and I guess that's the power they're getting. And I don't know what they're doing there. Looks like
maybe it's showing. It's like
hmm
getting power or something. It's like look at that. That's
so yeah,
I guess
so
that's the weight up there, right? That's the other
hmm
possibly, and then they're just floating around. I guess. Look at
yeah,
that.
that's their idea. And oh, it looks like a hotel. I see it's a space hotel. And you go up
Yep.
there and it's a space hotel. So in kind of in geosynchronous orbit. So there's all I'm there's all kinds of technical problems that have to be addressed, including the radiation that we talked about a few weeks ago. Um, and but you know, some people have thought about this idea that you could build a ring around the Earth, in geosynchronous and connect it with elevators in that manner. I mentioned that there is a way of getting around just being over the equator, in that if you have two tethers that are displaced from the equator by an equal distance, then you could have like a triangular leg, two triangular legs that attach to different points on the Earth. So you could
Oh
have
yeah, we talked about that too. Instead of
yeah,
just
so
one line, you have two.
yeah, so you could
Yeah.
have one tether, you have one tether at 20 degrees latitude and another tether at minus 20 degrees latitude, and they both go up and meet at the same point in geosynchronous orbit, and then connect to the counterweight that would then extend further on out. And so that would work. And there's some of the issues have to do with orbital debris,
Mhm.
because I mean, a tether, even if it's very thin, presents a tremendous cross-section area, and essentially it would be a target for every piece of debris, practically every piece of debris that's in orbit around the Earth. So it would have to be built so that it could tolerate, kind of like impact hits, and would be able to repair those. Um, so that's an issue. Uh, I'm not sure about, I don't know if we ever talked about the clear air electric field and the connection of the Earth to the ionosphere, but this would be probably a conductor, electrical conductor, or it would have elements of an electrical conductor that would then connect to the ionosphere. And if the ionosphere can collect enough, if the tether can collect enough electrons or ions from the ionosphere, then it would drive a pretty significant electrical current, or there would be a significant electrical potential between the Earth and the ionosphere that's actually supported by all the thunderstorms that are occurring all over the Earth. So I don't know exactly what effect that would have. But anyway,
I,
um,
I know I'm just scrolling through this because
no, that's
this
cool.
is interesting.
hmm
This guy built this whole website showing like this is what happens when you go in an
Whoops.
elevator, space elevator, and you keep going
Uh-huh.
up. I don't know what that is. Oh,
I
blue jets, lightning that arc
uh,
forward. Oh, I didn't even
and
know that. I think we
I think we
Mesosphere.
did talk about blue jets one
Yeah,
time.
we did actually.
Sprites. I
Mesosphere.
think we have
Yeah,
thunderstorm sprites.
high altitude balloon record. Wow, that's 50. How much is that? 53 kilometers up. I did not realize.
I'm
Just
not
going,
sure.
not even rocket.
Yeah.
But Oh, Saturn V. Okay,
Saturn
that's
V.
good. Good.
Yeah.
Hey, I do have to know. Oh, wait, what is this? We
Those
talked
must
about
be the sprites.
lights, right?
That
Yeah,
must be in the ionosphere.
that's like 70 kilometers up. Wow. Space shuttle reentry, and
Mhm.
then how far? You said that this, so it needs. Where, where do so you take the space elevator? It has to go to the geosynchronous altitude.
Yeah, I think that's 35,000 kilometers. So we aren't anywhere near high enough.
35. You mean okay? Where?
Yeah.
This is
We
70,
we have to be above the
By the way, this is 76 kilometers. Oh, 35,000. Okay, yeah, that's
1,000. Yeah,
yeah, yeah.
something like
Okay, what
that.
is this?
That's the aurora. It's either
And then yeah, and then what is it? You're about to reach a place fewer than 1,000 humans have ever been. Now leaving Earth, the Kármán line. I guess that's when we're actually in. Oh, was that it? You didn't even get to
Wow, that's
real
really
space.
lame. Yeah, it
That
didn't
is.
even get to
I'm
the
gonna
geosync. Yeah,
I'm gonna complain to this guy
yeah.
later.
But so the main people, the main people to talk about this are Silikovsky and the Russian guy that I'm not really that familiar with in the late 50s, a guy named Pearson. And then Arthur Clarke, who popularized it and made me aware of it because as a child, I would read,
Right, you
you
would
know,
read that.
yeah,
Yeah.
I,
Hey, for those people interested, I found this. There is a space elevator conference in Chicago. Do you know that?
no, let's go. Oh, it's already gone. Oh,
No, it's not.
August,
No, it's not. It's August 12th and
August
13th.
12th.
Yes.
I don't really have a paper to present, but I don't like to go to conferences unless I'm presenting a paper.
Yeah,
But
I feel the same way. I mean, but we can see. Would you be interested if you
I
did?
would. I don't know if I have the time right now in this short because August is coming off. August is just a few weeks
Right,
away.
right.
But that's kind of actually is pretty cool.
I mean, like
So,
this is kind of interesting that
mhm.
literally
But
the whole
I want
group
to
that
tell
did
you,
this.
I want to say, okay, I want to like this. I have a feeling that the material, even using the nanotubes, the carbon
Mhm.
nanotubes, I have a feeling that there are possibly insurmountable um, engineering difficulties associated with either being able to fabricate the nanotubes or even whether when you scale it up, whether you have a very long carbon nanotube, um, will you
Right.
will you actually be able to do this thing, right? And so I would I'd like to see some experimental work with
What
these.
can we do, like experimental wise?
Well, you could make a long, a 10-kilometer long nanotube cable and subject it to the kind of tensions that we do actual real tension tests on very long cables and see what we find. I have a feeling that I have a feeling, and I can't, it's not, I'm not being very scientific about this, but
Well,
I just think that you need another order of magnitude.
feelings could be scientific,
What?
but go on.
No, it's just a gut feeling that I have that you need another order of magnitude of material strength in order to do this. That the nanotubes are just barely possible, but I do think they are. I do think they're well within the possibility of doing it at Mars or the
Or the
moon.
moon.
Yeah.
Yeah, definitely. Huh.
Unless I missed something, I think that it's and
I mean,
it's just a fun, interesting thing to talk about and to study
let's see. What
and to
happens if I
speculate.
what
Yeah.
happens if I become a member of ISEC? Well, I pay them money. There. Okay. But what do I get? What do I do?
I
I don't know.
guess
I guess you just
you get the satisfaction of knowing that you're a member of the
Yeah,
ISEC.
International
Uh,
Society. What is it?
no, we're
International Space
yeah.
Elevator Consortium. There you
Yeah.
go.
Um
That's
well, no,
I,
I'm sure that you'll get on the mailing list and the money will be used to do these conferences and people, and
Yeah.
so I think it's a legitimate thing to
So I mean,
look into.
a lot of time, I mean, people typically say something like this, right? The transformational aspects of space. Well, I'm just quoting them here.
Uh-huh.
Traditional launch to Mars for an 8-month trip has a satellite departing the Earth's sphere of influence at roughly 4 kilometers per second after expending 13.1 kilometers per second of energy to beat gravity. This added to the velocity of the Earth enables flight to Mars. The opportunity or slash window to launch conjunction of planet alignments is every 26 months. When looking at release from space elevator, apex anchor at 100,000 kilometer altitude, the Earth's gravity field is
Uh-huh.
weak, therefore the release is 7.76 kilometers per second, and travel time can be as short as 61 days with
Yeah,
daily.
you would save a lot of energy getting into orbit,
Yep.
getting up out of the gravity well, because you could, you could just use you could you could use an electric motor, to lift. Now it might it might take weeks to get to um geosynchronous
Mhm.
orbit. Okay, so you're in an elevator and it might take a couple weeks, right? So
That's fine. You can live in that later.
you have to select your elevator music carefully. You need to, because
The
elevator,
longest elevator ride ever,
yeah.
for sure.
So it's actually probably more like a train, something like a train. But it's interesting.
I wonder
And
why it says this. With mining on the lunar surface, lunar space elevators become essential. I guess that's possibly true. I mean, if you're gonna make a
well,
large
we
profit.
can talk about building a linear accelerator on the moon and using that to launch stuff into space from the moon.
That was a wasn't that in another sci-fi book that I thought I
I
read?
I actually think it was in another sci-fi book
Uh,
by the same author, Arthur Clarke. So,
yeah, it like flung started flinging rocks at Earth or
mhm.
something. As
Well,
a yeah
the in
video.
Fountains of Paradise, the story hinges on a fictional country that is a veiled reference to Sri Lanka, which is where Arthur Clarke he he immigrated to there um, in the early 70s, I think, and he lived there most of the time in his latter life. And so um,
No,
yeah,
I didn't even
and
know.
so there it gets into the backstory having to do with um, the a king of this country, and they didn't want to build it there, and all this uh, political stuff having to do with that. So, but it has a pretty detailed the description of the space elevator and how it works, and and like that. And that's how I became this. It was this book that introduced me
Right.
to the idea when I was a child.
1979. That's when you were.
79. I wasn't a child in 79. I was a I was a I was 21 years old in 79. So
Okay, that's
I
not.
wasn't a child. Okay, so but I do remember reading this book.
Yeah, this is
Mhm.
interesting. I mean, it's just like, I mean, Arthur C. Clarke was pretty good at taking scientific ideas and transforming them into novels that
Uh-huh.
people would actually read and then get
Yeah.
excited about. So
Yeah.
that's
And
cool.
so and yeah, he also had a TV program in the 70s. It was called Arthur Clarke's Mysterious World.
Did you
And
watch that?
yeah, and you they're all on YouTube. You can watch
Okay.
Arthur Clarke. Oh, you're gonna do it. Go for it.
Not right now.
Oh,
I
okay.
don't wanna. I don't
Arthur
wanna put
Clarke's
out.
Mysterious World, and
I will.
he talks about all different kinds of things, including the crystal skulls in from Central America, and um, one episode one episode where he took a bunch of Sri Lankan grade schoolers, like third graders, and he put them in the classroom. Actually, the classroom was outdoors. He had them all in desks, and then he had a picture of Mars, right? And he put that at the head of the classroom, and he asked the children to draw what they saw on Mars. So it was an image of Mars, and some of them were able to um, reproduce some of the same kind of lines and canals and that kind of thing. That it was an experiment to see whether naive, young people, when they viewed the Mars, a picture of Mars from a
Right.
distance where it was blurry, they weren't able to make out all the little shapes, so that because in the 19 we didn't talk about Percival Lowell in the,
We mentioned his
right?
name before,
Yeah.
but back
Well,
then you're saying they
in
believed in aliens on Mars.
in the in the in the 20th century, up until about 1970 or so, it was thought that Mars, had canals on it, and that there might have been,
You see them.
plants, like um, uh, seasons and trees with leaves and that kind of thing, and that explained what was happening. What was visually observed. And Percival Lowell in the 19th century, early 20th century, he actually published his drawings of uh, of canals, because he was able to discriminate with his eyes that things that you couldn't see in photographs. And so he was the originator of this idea that there were canals on Mars. And so Arthur Clarke was trying to do an experiment with naive children, just third graders, and have them try to draw it. And if I remember correctly, some of them they were actually connecting points on the pa- piece of paper that he gave them as with straight lines. So that I thought that was interesting. So I'll have to watch that again. Arthur Clarke's
I'm gonna
Mysterious
have
World.
I'm gonna have to watch some of that too. I would like
Yeah.
to see what that.
So
Yeah.
he was a television personality then. It was on at about the same time that I don't know, Leonard Nimoy did a show, and I've forgotten the.
Was that one good?
Yeah, that one was good too. It was almost the same kind of show. It was like a half-hour show, and
Huh. Yeah, I think I'll start watching some of these episodes and we can
yeah.
talk about it. That'd be fun. So I want to go talk about some other topic.
I know.
Shall we?
I would love to.
Oh, okay. Well, it's just a photo. You're gonna say whatever. Let's see what we got here. This is once again from the site that I normally look at to find these things. All right. Okay, the video is terrible, so I'm not gonna play it.
It's always terrible.
Well,
It's always terrible. I saw a blimp the other day. An advertising, one of those blimps that flies around and advertises a sporting goods store. And
Yeah,
I took pictures of it, and
you
I was
did.
careful to center the camera, my phone, when I was taking the picture.
Was it blurry?
And I zoomed in, and it wasn't blurry, and I sent it to you, and you immediately identified it as a blimp.
Well, that's because that's not an unidentified flying object, is it?
If I took the camera and I shook it a little bit, made sure that you only get a little bit of it, and then I would waver off so that it wasn't centered on it, and I could tell you it was a UFO. It was
yeah. Well, I mean, yeah.
So what's wrong with these people? Why can't they take pictures? I mean, there are more cameras on Earth than there are people.
It's hard sometimes, when something, especially if something is moving. Imagine, like, you took a picture of a blimp that was moving really slowly.
All right, I'll take a picture of an airplane tomorrow, and I'll send that to you, and we can analyze it.
If you have something that's moving really fast and the lighting's not good, then it's a lot harder.
So how is it that these UFOs are always finding places where the lighting isn't good? It's part of their technology, right?
This is another one of the things I need to do. Compile a bunch of photos of well-lit, not blurry UFO pictures.
I'm open to it. Okay. Right. And occasionally you'll show me these things and I'll go, that's very compelling.
Okay, so what is this thing?
I don't think this is going to be one of those, but
this is not.
Carry on.
So this is a tourist taking a selfie. I'm just reading this. Taking a selfie in Mexico, inadvertently captured something that appears to be a flying saucer hovering on the horizon in the background. This particular photograph seen in the video was reportedly taken last month by Ramiro Navarro during a visit to the picturesque dunes of Babal in the state of Coahuila. After returning from the trip, he sent some of these pictures to a friend. who noticed a dark saucer-shaped object in the sky behind him. He subsequently posted a puzzling photo on Twitter and joked that the alien suspected UFO saw me but did not take me. The tourist's strange selfie understandably garnered considerable interest online, and while speaking to a Mexican media outlet about his viral photo, he indicated that he had taken multiple pictures while visiting sand dunes, but only this particular image featured the mysterious object. As for what the anomaly could have been, some observers online have suggested that the tourists could have accidentally captured an alien craft cruising through the sky, while skeptical individuals put forward more prosaic explanations such as a bird or a drone. What do you think? I mean, look, that's so blurry.
I don't think anything about that. I
Okay.
really don't. I don't think anything about it.
Okay,
I think, what's his name? Ramiro?
Yeah, here, let's see. What is
his last name's Navarro.
Is that part of the picture? Is that part of the picture?
Well, that's interesting.
There he is. I don't know if that's oh, see that thing in the background right there. Does that look like
I see. He's taking a selfie.
Like, what is that?
And
yeah,
I don't know. Could be a blimp. It could be.
A
wow,
blimp?
I want to go there. That looks neat. Where is that? That's in.
That is in the dunes of Bilbao.
Bilbao.
Here.
I see. Dunes de Balboa.
Okay. Okay, see, that doesn't look like anything to you? Could be. Else.
I'm just reserving judgment. I don't know.
So,
dark saucer shape. So that's it.
I mean, could go to these dunes and check it out ourselves, I guess.
Bilbao. I like it.
Great, doesn't it? Like, what is this place?
Dunas de Bilbao.
32 number one thing to do. Yeah, probably that's the only thing there.
Coahuila. Okay.
That's wow. Okay, I'm not saying go there to try to find UFOs, but it does look pretty beautifal.
Yeah. Right. Oh, what she got? Looks like food.
I don't know. This is just some random
girl with food.
Random place. MexicoDailyPost.com. She had any food there? Oh, I guess it must be a tourist picture. But I mean, a picture taken to convince you to go over there, even though it's a desert. Okay, so
thanks for sharing.
Was not exactly convincing. I was not.
Nope.
So that happens. Oh well. What can I say? But you know what? You should still look up because you never know what you will see, right?
Hey, that should be a slogan for the show. You should
look up because you never know what you will see.
Yeah, because I've been looking down all the time. Of course, I find a lot of change that way.
Change,
like
yeah.
I
get it.
Right.
But what? I mean, if you look up and you see something really interesting, it could change. It could change your world. That was a really bad one. But that aside, so this has been SG2 on Space, the only weekly space show, as far as I know it. Episode 182, Space Elevator. Thanks, Leonard, for explaining a whole bunch
182. So we're closing in on 200 shows.
Pretty much. I mean,
that's amazing. I was thinking about this like 1,000 years from now. Like,
okay, go on. Let's hear it.
We're on the internet, right? And so everything on the internet is going to be like forever. So 1,000 years, we could be talking to someone 1,000 years from now, right? They could be watching us, as to find out what we're like. And I'm just wondering, what do we want to tell them?
Think about it. Saying like we're like these YouTube videos are like a time capsule.
Yeah, it's kind of like a time capsule because it gets when it goes into the internet, it just stays there forever. One of the things that I've in my lifetime, I've been able to I've been able to view things on television historically, like I don't know, like the president making a speech in the late 60s, or different things I would see on television, particularly newscasts. And over the course of time, I see them again on YouTube or broadcast again, and they've deteriorated. They were like, for example, you can go on YouTube and you can find a video of the president giving a speech in 1971, and it looks terrible. Okay, but when it was on TV originally, it was sharp, crystal clear, and I'm just testifying to that, and it was very clear. And so I believe that they were put on photographic film, and they're not. There's no conservation effort, or very little they're not preserved well, and so they've deteriorated. The film emulsion has sort of, the grains of the emulsion have sort of diffused out, and so it's just something I've noticed. I could show that to you, that some film of news events have deteriorated. They don't look like they did when they were new. You sometimes see that in movies also, like the movies from the 1930s, unless they've been restored, and a lot of them have been, have done a good job of restoring them. But it occurs to me that because it's all digital now, that we're going to be preserved. Our images now are going to be preserved the way they are, right, for thousands of
not going to
years.
be deteriorated, right? Like it's not a photographic emulsion. You're right.
It's not, and it's digital. And
is that why you're always wearing a headband on these?
No, it's not. No, it's just the way I am. This is me. Okay, I have
understood.
It's my swag.
1,000 years from now, people will notice you're always wearing your swag.
They're always going to see me, wearing the swag. There maybe one time I'll do it without the headband, but
sorry, I derailed.
I also have an anachronistic peace sign, which if you are watching from 1,000 years from now, this is not. I mean, it seems like a brief period of time, just 50 years earlier, that these were very common. Okay, but actually nobody wears these today, except me, right? So,
well, I was thinking about how archaeologists, like in the future, well, actually, no, like us today, we look at some ancient civilization, dig up their artifacts, and then we find some weird things, like little trinkets that people have in their homes, right? And then we're like, oh, this must be so commonplace everywhere, but really it's some weird guy who just likes having that around.
Yeah, so to the folks 1,000 years from now, okay, I'm wearing this because I'm a weird guy, okay? And I wear a headband. If you go to my office and somebody's looking, and you're gonna go, I'm looking for the guy with a headband.
Wait, has that actually happened?
No, but I mean, that's how you can find me. So I'm just talking to that person 1,000 years from now, who's as far removed from us as we are from, King Arthur or something. There was no King Arthur. Well, we can talk about that sometime. But Henry V. He was 700 years ago. But somebody like that in that period, and I'm different. You're not seeing. You're just seeing a random sample.
Right. I mean,
of a curious character.
Well, I mean, anybody who's watching this video 1,000 years from now will most likely be also watching other videos, and they're going to have. Ideally, this is not the only type of video only video that's preserved from this time.
Well, I would hope that would be that would be the case. Now, the truth of the matter is that the artificial intelligence will have taken over. So, and it's not going to let us live. So,
well, I would like to not speculate about that kind of feature.
I don't know, but if you're watching this 1,000 years from today, be well.
Be well.
Yes, this is our show on the space elevator.
All right, so that was like the biggest tangent that's ever been thrown at the end of the show. End of this show.
I've been restraining myself. I
appreciate that, Leonard, for inserting that thought into my head, which has never appeared before, about people 1,000 years from now watching this, as well as for our viewers.
That's what I'm here for.
So, with that said, we do have to say, concluding the show now. If you do want to, learn more about space elevators, I actually put up a link right there, so you can go to
I will.
iscc.org, and then you can either sign up to attend their conference this year, or check out anything else on their website.
Just read. Just get
Awesome.
Arthur Clarke's book, and
that's another possibility.
Mhm.
If you want to read fiction, that there's the one that Leonard recommended for sure. So what is it called again?
Fountains of Paradise.
Fountains of Paradise. That's right, Arthur C. Clarke.
Arthur
Yeah.
C. Clarke.
So with that, we will call it a night, and take care, everybody. Namaste.
Namaste. Good night. Mwah.